This video is for the review for Module 13. I was asked to do 4 of the problems. The very first, of course, is the two graphs. So that's going to be 1a and 1b. So y is equal to 2e to the x plus 1 minus 2. All right, the base of this problem is the e. So that makes a equal to 2. That, of course, is going to be a vertical stretch. B is the number in front of x, so it's 1. That does absolutely nothing to my graph. H is the opposite of the x plus 1, so x is equal to a negative 1, which is a translation to the left 1 unit. And k is going to be the constant negative 2, which transforms this function down, translates it down. Okay, we need to know the basic parent function graph. It has two key features. It has a horizontal asymptote at y is equal to 0, and it has a y-intercept at the point 0, 1. It comes down to the left towards the asymptote and grows exponentially off to the right. The only 2 points that I said, I want to transform is the 0, 1 and the asymptote. The only thing affecting a horizontal asymptote is going to be k, a shift down 2 units. So my horizontal asymptote is at y is equal to negative 2. And I'm going to run the point 0, 1 through the transformations. So the very first thing that's going to affect it is going to be my a. My a only affects the y, so I'm going to multiply every y value by 2. And that gives me 0, 2. B does nothing to it. It would actually multiply the x values by 1, which would make it 0, 2 again. The next is going to be h, which is added to, or subtracted in this case, from every x value, because it's a left or right translation. So that's going to give me the point negative 1, 2. And finally, the same is true for k, except with the y values. I'm going to subtract 2 from that, which gives me the point negative 1, 0. So I'm at negative 1, 0, which is right here. And I'm going to just sketch in my graph. That's all I'm asking you to find. We could certainly find the the y-intercept. We would simply replace x with 0, which makes e to the first. E to the first is just e, 2.27. Multiply that by 2, subtract 2 from it. You get some value. I'm not interested in that, really. Domain, set of x is such that every exponential function is going to have the domain of all real numbers. So we're going to write it as a set of x's such that x is an element of all real numbers. You could certainly do it in interval notation also. The range will always be either from the asymptote up or from negative infinity up to the asymptote. So here we're going to be y such that y is greater than negative 2, or written negative 2 to infinity. So maybe the e messed you up. It's just like if it were a 2 or if it were a 3, it would be exactly the same. All right, b is going to be y, or g of x, is equal to negative e to the x minus 3 plus 1. Again, a equals negative 1. That's the negative 1 in front of this e. So that's going to be a reflection over the x-axis. So it's going to flip it upside down. B again is 1, doesn't do anything. H is a positive 3 this time, and k is equal to plus 1. So we're going to go right 3 units and up 1 unit. So the very first thing I'm going to graph is my horizontal asymptote, which goes up 1 unit. So it shifts up to y is equal to 1. And taking the point 0, 1 through the transformations again, a is negative 1, so that's going to be 0, negative 1. Or in your mind, you can think it just reflects down to here. You don't have to write this out. It does help. B is going to do nothing, so I'm not going to do it. H is going to be 3 added to x, 3, negative 1. And k, I add 1 to every y. So that's going to give me the point 3, 0. So I go over 3 units and up 0. There's my point. And it is a reflection, so it's going to look like that. where my domain is a set of x's such that x is an element of all real numbers. And my range, I'm going to go from negative infinity up to 1. All right, the next problem I was asked to do is number 4. Number 4 is a bacteria problem. You have the problems in front of you. So bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only one bacteria, which can double every hour, how many bacteria will there be after 1 day? Well, we got hours and days in there, so we do have to figure out what our doubling rate is in hours. So we want to put time in hours. The formula is going to be A, our ending amount, is equal to A sub 0, or P, which is principal amount, but the starting amount, times 1 plus R raised to the T. There's no R over N or N times T here because bacteria you can't compound. So we're going to have to know what A sub 0 is, what R is, and what T is. A is equal to the beginning amount. We have 1 bacteria, I believe, that we started with. And the rate. Now, there doesn't say anything here about a rate. It says it doubles every hour. Well, if it doubles every hour, you're going to get 100% more bacteria every hour. So the rate, we're going to put in a 1. And of course, time is going to be 24 hours because it is a day. So that's going to be 2 to the 24th power, or that would equal 16,777, 16,777,216. All right, on to number 7. 7 is during a normal breathing, about 12% of the air in your lungs is replaced after the one breath. So we're going to have the same formula here. A is equal to A sub 0 times 1 plus R raised to the T. So A sub 0 is, and I didn't read far enough, the initial amount of air in your lungs is 500 milliliters. We want to know how much is present of the original air after you take 240 breaths. So 1 breath is my time frame, so I'm going to do 240 times. The original amount is going to be 500 milliliters, and the rate is 12%, but it's a negative 12%. And that might have been the problem, or I wrote T like this, 240 on the solutions that I gave you, and when I substituted into the equation here, I put a wrong number. I wrote 24 and calculated incorrect. So maybe that's why you're asking. It is actually 240. So this is going to be 500 times, now you got to subtract there, 0.88 raised to the 240. And when you do that, you're going to get a really small number. And to be honest with you, I don't have it written down here. But I do recall that it was 0.000, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it was 5 something after that. And I don't have a calculator handy. It's going to come up on your calculator as this 5.3 something times 10 to the negative 11. And that's how you would write that out. All right, the last problem is going to be number 9B. This was 7. 9B. This one is a money problem, so we're going to use the formula A is equal to A sub 0, or P, principal, 1 plus R over N, now because we can compound money, raised to the NT. So we're going to have a principal amount, starting amount, we're going to have a rate, we're going to have a number of compoundings, and we're going to have a time. The time with money is always in years. All right, so number 9, I don't think there's any problem. It's $1,600 as the principal. The rate is given to you as 1.75. It's compounded quarterly. So how many quarters are there in a year? So we've got 4 compoundings. Happens every 3 months. And time, they tell me it is after, I'm looking, 3 years. So again, a quick substitution in. We're just going to have 1,600 times 1 plus 0.017. You got to make sure 5. Move that decimal over 2 places. Divided by 4. raised to the 4 times 3. So if you take your point 0.0175, divide it by 4, add that to 1, raise that to the 12th power, then multiply by 1600, you should come up with, where is it? $1,686.05. All right, guys, if you have any more questions, please do not hesitate to get in touch with me on Google Classroom. I'm happy to help you out. Thank you.